Welcome to all. Today myself M.REVATHI. I'm Department of Computer Science and Engineering from S.A.E.C Engineering College. Today I'm going to explain about computer architecture. In this, we are going to discuss what is ALU, the basic components of ALU, data path and control unit, which is an important topic in our GATE syllabus. So first we'll see what is ALU. ALU is nothing but arithmetic and logical unit. So the basic operations of arithmetic operations are as you know, like addition, subtraction and other basic operations are performed in this arithmetic and logical unit only. First the instruction has to be fetched from the CPU and you have to get it from the CPU and you have to perform all the instructions. So for example, so this is an first I will tell you the definition. Arithmetic and logical unit is a digital circuit that performs the arithmetic and logical operations on binary data. So each and every operations whichever is performing, it will be performed in the binary data only. Either it may be addition or subtraction or shift operation, whatever operation, the basic operations will be performed in this ALU unit only. So ALU takes the input from the register and performs the operations and produce the output. I'll show you the diagram. This is the basic diagram of ALU. So if you see this one, this is an integer operand. So for example, I'll tell you some real-time example. If you want to add two numbers like 2 plus 3. So 2 is an integer number. So the 2 will be stored here, that is in integer operand A, and 3 will be stored in the integer operand B. So it will be performed. So what is this operand means? It is nothing but an addition, subtraction or multiplication, whatever operation you are telling, that we will call as an operand. What is opcode? Opcode is nothing but the symbols which we are using. For example, for addition we will be using plus symbol and for subtraction minus symbol. So the symbols what we are using is called as an opcode. And what is this status? It is nothing but a carry in and carry out status. For example, I want to add 3 numbers 1 plus 2 plus 3. So first what you will do, 1 plus 2 it will add and it will store that 3 in some memory, some temporary memory. That is what status, that is carry in and carry out we will be calling. So the carry out is nothing but, that is not the final result. 1 plus 2 plus 3, in that 1 plus 2 we will get 3. Again that is not a final result. Again we want to add one more 3. So for that purpose means we need to store somewhere in that 3. So that is what carry out. That carry out will be a input for the next operation. Okay, so this is a carry out status and this is a carry in. This status, this output will be input for some other operation. So this is what two status. One is performed for carry out and another one is a carry in. So the final result will be getting as an integer result. So this is the basic ALU diagram. Next, so what are all the things? That's what I have told you. What is operand means? The two input operands are A and B and result output is a Y. So this diagrammatic explanation, what is operand, what is opcode, what is status and what is integer result, that's what I have explained there. A and B is nothing but whatever operation you are performing, that is whatever input you are giving, A and B. For this A and B, what input you are giving? For example, 2 and 3 means 2 will be stored in A and 3 will be stored in B. That numbers we will call as an operand, and inside what you are doing, what operation you are doing, that we will call as an opcode. So that is what it is given here. Arithmetic and logical symbols, either addition or subtraction or multiplication, whatever symbols you are giving, that is known as a opcode. And status is carry in and carry out. That's what I told, that is carry in bit that is stored and carry out from a previous ALU operation. So any carry means if you are adding, you will be getting some result. So temporarily you want to store that result somewhere, that is what carry out. That result will be an input to the another operation, that is nothing but a carry in. And status signals is nothing but carry out, 0, negative, overflow, parity. So there are 5 status signals are there. carry out, as I told, if you are doing some addition operation, you will be getting some result. That result we will call as a carry out. Either it may be a positive or negative. So you have to find out whether it is a 0 or positive or negative, or it is an overflow or parity. Parity is either it is an even or odd. That checking is known as a parity checking. And overflow is whether it is exceeding. Suppose I am adding 2 digits, but the result will be 3 digits or 4 digits. That we will call as an exceeding overflow. Okay. So these are some status signals. Status signals will be probably this 5 status only. Most probably this 5 status only. Either it will be a carry out or 0, negative, overflow or parity. Parity is for even or odd number. Next, so what are the registers you are using? Registers are a small amount of storage available to the CPU. These registers can be accessed very fast, and the control unit tells the ALU what operation has to perform on the available data. So register is nothing but it is an amount of means where you will store your instructions. Okay, so that is a storage available in the CPU, and these registers, what it will means, it will tell to the control signal, next operation it has to do this one, next operation it has to do this one. The control signal will be performed through the control unit, and after calculation everything, after calculating all the things, the result will be stored in your output unit. So where it is, how it is carrying, information is passing from register to CPU or CPU from some other place. How it is carrying? All through bus. What is bus? So bus is nothing but a communication system that transfer data between the components or between the system or between two systems. So whatever it may be, the transfer of data from one place to another between the computers or within the computer is nothing but a bus. So we'll be seeing what is bus and what are the various types of bus are available. So that we will be discussing this clearly and one by one with clear information. So it includes hardware components like wire, optical fibers, etc., and software including communication protocols. So both hardware as well as the software particles are available here. So this is mainly purpose of communication protocols, that is transfer of data from one computer to another computer or within the computer from one component to another component. So we will see what are the so this is the overall structure of a bus. So what all the things are available in this bus? So if you see, there are so many registers are there. One is a general purpose register, PZ is nothing but a program counter, IR is nothing but an instruction register, then MER is a address register and data register, memory address register and memory data registers, and you will be having your ALU. Just now we have seen now what is ALU, that is basic operations will be performed in this arithmetic logical unit only. So these are register A and register B. So the input whatever you are getting from the user, that will be stored and the operations will be performed here only. Okay, so this is a basic diagram how it is performing. What is program counter, what is the use of program counter, we'll see each and every component detailed. So first one is an instruction register. Instruction register is nothing but what is the purpose of this instruction register. So here it is an instruction register. So the main purpose of instruction register is what execution what instruction is currently executing. What is the currently executing instruction? That will be stored in the instruction register. And what is program counter? Program counter is nothing but it will store the address of the next instruction. Say after this instruction register, I told the currently executing instruction. So next after this currently executing instruction, what is the next instruction it is going to be performed? That will be stored in the program counter. So program counter is nothing but the address of the next instructions. That is after completing the currently executing instruction, what is the next instruction it is going to be performed? That will be stored in the program counter. What is this memory address register and memory data register? These both register will be direct contact with the CPU, that is it will be stored in the memory itself. So it carries the address of the memory. So I told here next instruction will be executed. What is the next instruction? It is going to be executed. That address will be stored. All memory address will be carried out by this memory address register. And what data it is? For example, I told very beginning in 2 plus 3, if you want to add, that 2 and 3 is nothing but a data. The data will be carried out. The 2 will be stored here and 3 will be stored in the register B. So that data will be carried out by this memory data register. What it has to perform next, that will be which instruction it has to be execute, that is what program counter, and what is currently executing is nothing but a instruction register. What address it is carrying out, that is nothing but a memory address register. What data it is carrying next, so what is the data it is carrying to the particular register, that is nothing but a memory data register. So these are the main purpose of register. And one more is a general purpose register, which is nothing but a register which is used by our user or programmer. So mostly we will be using this general purpose register only. This is direct contact by the CPU and this will be used by the user or programmer. What is the purpose of general purpose register? It is nothing but a temporarily, if you want to store some data, then it will be stored in the general purpose register. All the data which is stored temporarily, that you want to store it in the general purpose register. And I explained already what is ALU and what is this register A and register B will do. So you will be storing all your operands here and your arithmetic operations will be performed here. So this is the basic structure of a bus organization. So what we have discussed, that's what I have given here, that is instruction register. The instruction currently being executed are decoded, then program counter, the address of the next instruction to be executed from the memory, and memory data register and memory address register. This is direct contact with the CPU, so it will carry the data and it will carry the address of the register. General purpose register, it is used to store the temporary data within the microprocessor. So if you want to store some data temporarily, then we have to use the general purpose register. So this is the overall bus. What is bus? So here in this also there are various types of bus are there. So one is address bus, data bus, control bus and power bus. So these are the main 4 types of bus. So first one is address bus. So from the name itself we can identify what is the purpose of address bus. It transfers memory address from the processor to components like storage and input output devices. It is a one-way communication, means it will carry the address with which instruction it has to be executed. That address will be carried out by this address bus, that is it transfers memory addresses. So from the processor to the components where you want to transfer it to that particular component, it will transfer the address. So that is the purpose of address bus. Next one is a data bus. So if you want to carry the data from one component to another component, then you have to use the data bus. It carries the data between the processor and other components. So the data bus is a bidirectional. So what is the meaning of this one directional and bidirectional? Means the address will be in a one directional. Again it will not send back. The address will not again come back to the source place. Source and destination place is there, means it will not again come back to the once it is reached to the destination, again it will not store it into the or come to the source place. But this is a bidirectional. For example, if you want to store add 2 values, first it will store get the input from the user, again the output will be given to the user. So it is a bidirectional. Control bus. So all this happens with the help of this control signals only. That control signal is carried out by this control bus only. After getting control signal only, this operations will be happened. Next control has to be this one, next one has to be this one. So it carries the control signals from the processor to other components. All the things will happen. This is the main important. Without control signals, other things will not be performed. So it carries the control signals from the processor to other components. The control signal is a unidirectional. Like your address bus, control bus is also a unidirectional. And last, power bus. What is power bus? So it carries the clock pulses and power signals. What is clock pulse and power signals? So while doing all these operations, while performing all these operations, which clock has to be, means from this it has to travel from this distance to this component to this component. This particular clock pulse has to be on, this particular clock pulse has to be off. So that will be taken care by this power bus. So all the time all the clock pulses will not be switched on. So only for particular reason only the clock pulses will be activated. So that everything will be taken care by, that responsibility will be taken care by this clock pulses. That is what power bus is. Then coming to data path. So what is data path? It's nothing but a collection of functional units that perform the data processing operation, including ALU, registers and buses. So in this diagram, all the ALU, registers and everything will be taken care by this data path only. So that's what, collection of units that perform the data processing operation, including ALU, register and the buses, together we will call as a data path. So it will, what it will do, what is the main purpose of data path? It allows the data to flow in between these units. So any data processing, any operation that happens in the CPU and then for data operation, that the data flows in a specific path, we will be collectively known as a data path. So what all the things are present in the data path, that we will be seeing one by one. So this registers, ALU and the interconnecting bus are collectively referred to as data path. So next one is a control unit. So what is this control unit? So I told, without control signals nothing will be activated. So by getting the control signals only, all the other things, all the other components will be activated. So the control unit is a very vital part of the computer CPU, that is central processing unit. The concept of control unit was first introduced by John von Neumann. So the control unit responsibility is to guide the computer's arithmetic logical unit, memory and input-output devices on how to react to the commands given to the processor. So as I told, all the things, all the other components will activate only with the help of control signals only. Without getting control signals, either it may be a register or memory unit or ALU, nothing will be activated. To how to react the command, whatever the command which is given from the or fetched from the CPU, how to react for that particular command is based on the control unit only. So that's why it is called as very important. So this is the block diagram of a control unit. So this is the central, that is control unit. You will be getting all the flags and clocks, that is the signals will be getting, and the control signals within the CPU and control signals from the control bus and to the control bus. So that will be taken care by this path, and instruction from the instruction register you will be getting the all instructions, what it has to perform, what is the next thing it has to perform, all will be getting from the instruction register. So that is, I already told IR means instruction register means which instruction is currently being executed. By getting the control signal, the current IR will taken care by the currently executing instructions. So control unit retrieves the internal program commands from the main memory and moves them to the processor instruction register and produces the control signal based on the register's contents to manage the execution of these commands. So how it is working, how the control unit is working, that's what given here. So the control unit gets data from the user and convert it into the control signal and then passes these signal to CPU, that is central processor. Once the instructions are getting from the user, after that it will pass that, convert that control signals and it passes to the central processor. After that the computer processor, then it will guide where it has to go. That is, it will connect connect to the hardware on the task to perform. So what task it has to perform, that will be taken care by this computer processor, and it will guide to the connected hardware. Since the CPU architecture means it will not be same for all the control unit, will not be same for all the system. It varies from system to system. Maybe because of one manufacturer to another manufacturer, the functions will be carried out by the control unit in a computer depends upon the type of the CPU what they are using. It may be varying. So either it may be a central processing unit or graphical processing unit. So that is what are the roles of control unit. It manages the flow of data into, out of and between the different subunits of the processor. Whichever component is working, either it may be ALU or register, a PC, program counter or instruction register, whatever component is working, because of control signals only. After getting control signals only, each and every component will be, the data will be flowed. That's what it is given here. It manages the flow of data into, either you are getting input or you are giving some output, or in between if you want to transfer some data, with the help of control unit only you can do it. Otherwise, without getting the control signals, you cannot transfer the data or move the data, or you cannot perform any operations. That's what I have given in the first point. Then it can interpret commands and instruction. It regulates the flow of data within the processor. It can accept the external commands or instruction which it transferred into a series of control signals. It oversees the multiple execution units of CPU such as ALU, data buffer and register. It also performs the various operations including fetching, decoding, managing execution and storing the results. So how it is fetching the data and decoding the data? So once the instruction is given, that is fetched from the CPU, we need to decode that instructions, and you have to manage the execution, whether it is a addition operation or based on the input which is given by the user, you have to perform the operation. So how it is doing all those things, I'll explain with one example so that you can understand. So this is a different types of control units. It is a basic types of, so various types are there. This is a basic type. One is a hardware control unit and another one is a another one is a micro-programmable control unit. I'll explain you one by one. So this is a hardware control unit. So hardware control unit means everything will be, from the name itself you can able to recognize. That is, if you want to change something in the hardware control unit, physically you have to change some wire or microchip or something you have to do in the hardware parts. You cannot do it in a logical manner. That is, you have to do it a physical manner. The hardware control unit, the necessary control signals for the instruction execution control are generated by specially designed hardware logical circuit. The signal production mechanism cannot be changed without physically altering the circuit structure. So something, if you want to do some changes, you cannot, without the physical action you cannot do some changes. So with the manpower or some, you have to do it physically. That is the difference between the microprogram and hardware. The main difference is hardware means everything will be in a wired manner, that is we have to do it physically. But in microprogrammed, if you see, you can do it in a, that is with the help of coding, or you can do it automatically without the help of physical help. Okay, so that is the main difference. I'll show you with the block diagram. So this is the main structure of hardware control unit. You will be having the timing unit, that is rectangular signal from quartz generator. So after getting timing unit, it will be passed to the next control state generator. From the next control generator, it will go to the control signal generation matrix. So from here it will control signal for other computer or computer unit, it will be passed. So as you know, from the instruction register you will be getting all the instructions. That will be divided into two things. One is opcode, that is what operation. Opcode means I told you what symbol it is using, either plus or minus. That opcode is nothing but a symbols what you are using. And what is the address field, address of that particular instruction. Either it is a program counter, means address of the next instruction. So what address field it is. So the instruction register, it will come to the instruction decoder. So first it will fetch the instruction, then it will be decoded. After that it will be passing to the control signal general matrix. So here we have seen now, that is the instruction will be fetched, decoded and managing the execution and storing the results. First it will be fetched from the CPU. After that we need to decode that particular instruction, then it will be performed some operation. So this is a basic diagram of a hardware control unit of a computer. So next, microprogrammable control unit. So here, as I told already, this main difference between the unit structure and the hardware control unit structure is the presence of control store. That is, the control store is used to store the words containing encoded control signals necessary for instruction execution. It is not mandatory that you have to do it all the signals with the help of physically some changes if you want to make. It is not compulsory you have to do it physically. You can do it, or we can control those signals with the help of instruction execution itself. So this is a microprogrammed diagram. So the same way here also the control, everything will be in a smaller chip. Everything will be activated with the help of commands only. Okay. So the instruction, this and all same, instruction registers and all same, opcode will be there, then address will be there, then from that we need to decode it. So before decoding, so the micro instruction address generation unit will be there, from here it will be going to. So if you see that the hardware directly from the opcode or instruction register, here it will be decoded. But before, in this microprogrammed, before decoding you will be doing some micro instruction address generation unit, that is with the help of state information from execution unit. So you will be giving input this, then after that it will go to the micro instruction address register, then after that only it will be decoded, then the control will be stored in the control store. Okay, so that is the main difference. Again, the operation part, control and address part. So here opcode and address will be there. So here again it will be divided into 3 parts, then if necessary again it will be decoded to the nano instruction memory. So if you see one problem, you can able to understand clearly what is data path and what is control unit, everything. So this is a question which is asked in GATE 2020. So consider an instruction R0 equal to R1 plus R2. The following steps are used to execute it over the given data path. Assume that program counter, PC is nothing but a program counter. So program counter, as I told, what is the purpose of program counter? It will store the address of next instruction, which is going to be executed next. That address will be stored in the program counter. Instruction register is what instruction it is currently executing, that is what IR. PC is what is going to be executed next, that is PC. Is incremented appropriately. So that means what? Beginning itself, somewhere that program counter is incremented appropriately. That is given in the question. And the subscriptor R and write, that is read and write. R mentioned for read and W is for write. Indicate read and write operation respectively. So this is the block diagram which is given. What you have to identify is they have given some set of instructions. So R2 or that is read R2. R2 means it is on register. Register name is R2. And small r means read. Read the register R2. Temp1 means it is a temporary memory. Temp1 is a temporary memory. Again it is R means read. ALU is nothing but a arithmetic logical unit. I told all the basic operations will be performed in this arithmetic and logical unit. So what operation it is happening? Add. So they have given addition operation is performed in the arithmetic logical unit. And temp to W, what it is meaning? In the temporary 2 register it is writing. First it is reading, in temporary 1 register it is reading, again temporary 2 it is writing. This is the instruction they have given. Like this second instruction R1 is a register 1 read, temp 1 means temporary register write. This is the second instruction. Third instruction they have given program counter memory address register. MAR I told, memory address register. What is the purpose of memory address register? It will store the address of the memory. That is address of this particular register, it will be carried out. Then NER, again it is for reading that address, memory address. Then this is for read. Temp2 is for temporary 2. that is temporary 2 read, R0 is another register write, MDR is a memory data register read, and IR is a instruction register W. So this is what they have given 5 instruction. Now what is the question is, which of the following is a correct order of execution? So this is not a correct order actually. So we need to find out which is the correct order, and you have to number it. So first thing, what is the first thing I told? So this is the diagram. Once the instructions it is given, what is the first thing it will do? So it is nothing but you need to fetch the instruction from the CPU. So you need to fetch the instructions from the CPU. First thing is that one, fetching. After that you need to decode. That is the second thing. So fetching means where you will do? So with the help of PC only. What is the next instruction it has to be executed? That will be stored in, I told, PC. So in this, where a PC is given? In instruction 3, PCR. In PC, what is the instruction it is stored? So after that, what it is doing? MAR. It will store the address of that particular register. So program counter in this, any of the register means any of the instructions, third one only they have given PCR. So the first instruction which is going to be executed is a 3. So third one, PCR, MERW, MER. So PC is the, from here instruction will be fetched. Again MER, the address of the next instruction, or address of this particular register will be find out. So third instruction is the first one, it has to be executed. Okay, we have found the instruction and we have found the address of that one. What is the next thing it has to do? Next it has to read the data. So where it will read? So MDR, that is memory data register, instruction register W. So after reading, it will store it in the memory data register. What data it is given? User has to give some input. They said clearly R1 plus R2. So some addition operation they are doing. That they have given clearly. So addition operation means first it will store one data in the temporary 1. So before doing that addition operation, what you have to do? You have to carry the data. So that is, carrying data is nothing but a MDR. So what is the MDR instruction given in the question? It is nothing but that is MDR write and IRW. So after getting input, it will be stored in the instruction register write. So next instruction, so first I told, third instruction will be executed first, then fifth instructions will be carried out next. Then what it will do? We have got the input. So suppose you assume that 2 plus 3 you are going to add. So you got the input 2 and 3. What you have to do then? You have to store it in the temporary variable 1. So where is the temporary variable 1 here? So if you see 1 and 2 both are there. First you will be storing in register 1 only, R1 only. So temp1 R1R and temp1 W. This is the next instruction it has to be executed. So first one is a 3, next one is a 5, and next one is a 2. That is option D. I'll tell you the complete thing. So after finding 3 instruction itself, we come to know what is the answer. Still I will explain all the things. So second instruction is nothing but a R1R and temp1 W. So next instruction is the first one, that is R2. That is after adding this one, temporary 1 you will be having 2. After that you will perform 2 plus 3 you will be performing. That is you will be having 2 plus 2 comma 3. So that will be performed by ALU. In ALU they have said addition operation, that is 2 plus 3. Again the 2 plus 3 will be stored. Where it will store? In temp2 only it will store. So what is the temp2? That is R2 temp1. Then after performing ALU add, it will go to temp2. So this is the next instruction. It is supposed to be executed. That is instruction 1. At last the result will be stored in the temporary 2 and again it will be stored in the R0 register. that is temporary to or not right. So that is the last instruction, it has to be executed. So what is the order of this instruction? 3 is the first, and 5, again 2, after that 1 and 4. So what is the result, that is what is the answer for this one? D is the correct option. Answer for this one is a D. So I explained this instruction. First, it will send the address to the memory through MAR. After that, the read the opcode into instruction register from the memory through MBR. After that, send the first operand to temporary one, that is ALU, arithmetic operations will be performed. Then read the second operand directly from R2 and process the data in ALU and store the result in temporary 2. Store the result into R0. So this is the final solution for this one. That is answer D is the solution for this one. 3, 5, 2, 1, 4. This is how the instruction will be executed. This is one of the important questions that is covered in GATE. So under data path, you will be getting questions like this only. So that's all. Thank you. We'll see you in the next session.